we wanted to talk, one of the biggest reasons that weather data is important is for irrigation management. And that's because we can use weather data to estimate crop water use or evapotranspiration. So evaporation of water from wet leaves and off the soil surface, as well as transpiration, which is water that comes up through the roots and then goes out the leaves. So evaporation plus transpiration, that's where we turn water into water vapor. And so this is consumptive use of water. I mean, that water will leave the basin and will never return. Well, maybe, but it's untrackable really at that point. So we count it as consumptively used, even though it's still in the air. But that really is water use. So in order for us to do irrigation water management, we need to know what this is so that we know how much water to put back in. So we can keep track of how much water the soil can hold. And then we keep track of rainfall, which is measured at the weather station. And then we can keep track of irrigation, how much water we apply with irrigation. And then we can use that to estimate when to irrigate and how much. So this is the basic equation. The soil water content at like tomorrow is today's soil water content plus rain plus irrigation plus capillary rise. If you have a high water table, you can get water that rises up into the root zone from there. But usually we assume that that's zero. And then you subtract the ET, you subtract deep percolation. Deep percolation is if you put too much water on, or if too much rainfall, then and the water flows out of the bottom of the profile, and then runoff. So all of that. So usually we hope deep percolation is zero, we hope runoff is zero, we hope capillary rise is zero. And then what we can do is we can get rainfall, irrigation, and ET is left, and we can use that for doing irrigation water management. So that ET data also gets used for like basin scale water balances, for river basin planning, for municipalities, um, uh, and uh, and plants really are the amount of water that plants use is really large. The consumptive use of water, if we're thinking about only that, it's 95 to 98% of the water that gets consumptively used for us. In other words, consumptive use means it goes into the air, is to grow the food that we eat. So it's large. There's some direct ways of measuring ET, which is basically what we have to do is we have to either have some sort of an accurate soil moisture sensor within a closed basin where we measure the soil moisture, and then the water coming in, we keep track of water coming in, and then the difference in soil water content, we can use that as a way to estimate ET. But that's difficult and kind of fraught with uncertainty and error. The best way to do it is where they have this big box full of soil. It's called a lysimeter, and it's buried in the ground. So this is the ground surface, and this is kind of this underground bunker thing where it's kind of hidden. And then you have this this whole thing is weighed continuously, and we can weigh the differences in water as it's evaporated from the soil surface or is transpired. We can use that to as a direct measurement of ET. So here's another weighing lysimeter. Of course, these are very expensive to build, own, and operate. But this is one direct way of measuring ET. What happens around it is also very important. So, water use at the edge of the field does not represent water use in the middle of the field. And so has to have lots of upstream fetch. And so ideally, so underneath the ground is where this bunker thing is. And here's this large weighing lysimeter, and you can see that it basically looks like a field from the top of the soil. So these are really expensive. It's really hard for us to do this. There's other ways to measure directly, estimate crop water use for irrigation management, but those are also expensive, like eddy covariance towers and stuff, and I'm not going to get into how those work, but suffice it to say it's expensive. But what we can do instead, and what most people do, is they take weather data. You use weather data to estimate how much water a reference crop is using. And there's two different reference crops that are commonly used, and it's important to know which one is being used where. In the Pacific Northwest, we like to use alfalfa as a reference crop because the alternative reference crop that is also used is grass. And we just don't think that there's many crops that are, a couple centimeters tall, and it just doesn't represent the way that those crops interact with the air and stuff. So anyway, we like to use alfalfa as a reference crop. And we can calculate what that reference crop of alfalfa is using on any given day using weather data from the weather station. So here's a typical weather station. We have solar radiation coming in, and that's the primary source actually of energy. This whole equation that estimates reference evapotranspiration is an energy balance equation. So just like mass, you can't create or destroy mass, it just changes form. You can't create or destroy energy either, and it just changes form. And so all the energy in has to equal the energy out. And so they keep track of all the energy coming in to the plant surface, and most of that is solar radiation. Also calculates energy that goes into the wind, can add or subtract energy from the and then how much that it can add or subtract depends on the humidity and the temperature and the wind speed. Anyway, it's a fairly complicated equation, but suffice it to say it's been calibrated, and it does a reasonable job of estimating how much water a reference crop, which is tall alfalfa, not clipped or cut alfalfa, it has to be tall alfalfa, how much that would use on a given day with those given weather conditions. And so then we take that and we multiply it by a crop coefficient that is specific to that crop and that crop's growth stage. So crops, all crops are different. They're not like alfalfa. So we multiply it by a coefficient that takes into account those differences. And also, as those crops develop, they have, before they bud out or before they pop out of the soil and they get taller and bigger and they develop and close the rows and use all the sunlight, they use more and more. And so those crop coefficients are going to change over time as well. So here's what reference ET would look like over a typical season. So this is how much water alfalfa would use on a typical season. So here we started in May and then all the way through October. A couple of things you can see is first is it just bounces all over the place, and that's because weather changes. And so it's really important to have some sort of a measure of how that weather is changing so that we can adjust our crop water, our irrigation to account for that. So it bounces all over the place. And then look at how much this shape too. If I'm irrigating the same at this time of year right now as I am in the middle of July, I'm going to be doing it wrong, right? I'm going to be over irrigating if I'm irrigating at the same rate now as I am in the middle of, and I might be under irrigating if I'm irrigating at that same rate in the middle of the July. So again, we just need that estimates of weather data in order to capture how that changes in day length. So I went back. So solar radiation, temperature and humidity, wind speed, and what's the other one? Humidity, temperature, humidity, wind speed. So those four things, those are the primary inputs into that equation to estimate crop water use. We also need to know latitude and longitude and some other things about the weather station, but we can get that. Then that reference ET gets multiplied by a crop coefficient that also changes over time. So here, the crop coefficient as it pops out of the ground, germination and emergence, then vegetative growth, it gets bigger and bigger. It's creating this infrastructure that it's using to capture sunlight and CO2 and create and do photosynthesis and turn it into the good things that we want out of crops that we're growing deliberately. So here's kind of generally what it looks like, but we can simplify that curve using these 5 points that people can relate to, and 3 numbers: this initial, the full cover, and then this final crop coefficient. This is a simple way to kind of try to estimate what the curve looks like, in a way that people can change those numbers and adjust them so that for their different crops. So here's kind of shows how typical crop water use changes. So winter wheat, obviously it uses it early in the season, then it gets done. And then safflower and some of these things get done later. Potatoes, wheat, corn, and things, they like warmer temperatures, and then they grow and they peak. And then alfalfa kind of uses water throughout the whole season, as do all forages. So this shows, again, so this green line is the mean. So we took a 30-year average of the mean crop water use of a particular crop. And the blue lines are plus or minus 1 standard deviation. So it kind of shows you how that bounces around. And then for reference, we also included this orange line to say, okay, these are the mean, but this is what a typical season looks like. So we use that with kind of information that we know about the soil. First, we know that soil is basically just a bunch of little rocks, and then there's space in between the rocks. And if you fill all that space between the rocks with water, it's called saturation. The technical term, I believe, is mud. And if you let that water drain through, then it'll, at some point, the soil will hold the water long-term against that pull of gravity, and that's called field capacity. So field capacity is the maximum amount of water that the soil can hold long-term against that pull of gravity. And then as it dries down, you'll get to what's called permanent wilting point. There's still water left in the soil, but it's unavailable to the crop because the crop, it's held so tightly by the soil. And then the pathways for that water to move around in order to get from the spots in the soil where it's held to the roots, they get so tiny and thin that it just can't get there anymore. And so when we do irrigation management, we manage the soil water content between field capacity and the permanent wilting point. And of course, different soils hold different amounts of water because mostly where those where the water is held is where the particles come together. It uses the capillary forces of the water where it's hanging onto the soil particle, and it's also hanging on to the other water molecules, and it kind of allows that to hold water. And so the more of those spots where the 2 soil particles come together, the more water it can hold. So in general, coarse sands don't hold as much water, and then silt loams and clays and peats, etc., can hold a lot more water. Yeah, so the inches that the units that we like to use are all in 1 dimension, just like for ET. Also, we use, it's the same as rainfall. So we measure rainfall in inches. We measure snowfall in inches. So we like to use ET in inches as well, which is inches of water everywhere. And then you can use soil water holding capacity as inches of water that it can hold per foot of soil depth. And that's a useful number because you just multiply this times the roots, the depth of soil that roots are in contact with, and it gives you the total volume of water that the soil can hold. So it's basically a nutrient. It's a reservoir. It's a bucket. The soil. The size of the reservoir depends on 2 things: that water holding capacity of the soil and the root zone depth. So the larger the root zone depth, the bigger that bucket is. The larger the water holding capacity is, the bigger this bucket is. And so in order for us to do irrigation water management, we need to know how big the bucket is and then where this water level is in here. And then this number if we can keep track of how water leaves, how much water leaves the bucket, then we can get an estimate of how much space there is in here for us to irrigate, so that we don't overfill the bucket. If we put more water on the soil than it can hold, it'll go into the soil, it'll probably make us feel good because, oh, it went into the soil, but the soil can't hold it all. It's going to keep on going out the bottom of the profile, be lost to deep percolation. So that's, you can kind of think of that as overflow in the bucket. The bucket is only so big. So the other thing you need to know for irrigation water management is, so here's fill capacity, this is full. Here's permanent wilting point, this is dead plants, it's so dry it's dead. You get maximum production as you dry down for quite a while, but then there's a cliff where we choose, and we call this MAD, or management allowable depletion, or maximum allowable deficit, or something. Everybody uses different terms for that, but that's when you're going to begin to experience water stress. And so the plant's going to go into this self-defense mechanisms. It's going to close the stomates. It's going to roll the leaves. Corn has the leaves roll and the spikes. The grass often has a leaf that opens and then it'll close. It's trying to protect itself against water loss. It's deliberately trying to reduce water loss so that it can survive the coming drought. But when it does that, it also limits its exposure to the sunlight. It limits its exposure to CO2 exchange. It basically reduces photosynthesis, and it reduces yield of your crop at that time. So if we want maximum production, then we manage the soil water content between field capacity and this MAD. This curve looks different for every crop. Some crops are very water drought tolerant, and it'll maintain maximum production for quite a while before it starts dropping off. Some are like potatoes and vegetables are infamously pansies when it comes to water stress, and it just starts losing yield right away. So this MAD number is going to be different for each crop. And if I'm trying to impose water stress, like for wine grapes, then we deliberately want it to be over in this water stress portion. And if you add a lot of water, it's going to go all the way back up here, and it's going to have no stress for a while, and then water stress. If you want to maintain it in this small area, then it's useful to be able to irrigate small amounts, which is why drip irrigation is often used with wine grape production, because you can irrigate small amounts. Okay, I'm okay. I'm looking at my time. So over time, so this is time on this x-axis, and then on the y-axis here, this is the total volume of water in inches of water that's in the soil, the entire soil profile. So this is the water holding capacity multiplied by the root zone depth. So here's field capacity, here's wilting point, here's that water stress line. If I have water, if I keep the soil water content, which is this blue line, between these two lines, I'm going to have maximum production. So every day ET decreases the soil water content. And then if there's rainfall events, which are these little lines here, it pushes the soil water content back up. It can't go above field capacity because we're assuming that that water gets drained out the bottom of the soil profile. You can't hang on to it. But it goes above. If you watch this in real time, it will go above field capacity, but only for a short amount of time, like half a day or something. Anyway, so we can model this soil water content over time. And the idea is to keep the soil water for maximum production between field capacity and this MAD point. So quick soil water budget. If I have a silt loam soil and my available water holding capacity is 2 inches of water per foot, I have effective rooting zone of 1.5 feet, then the total, this would be different for every crop, but in this case, this is like for a vegetable or something, 1.5 feet, 2 inches per foot times 1.5 feet, that's 3 inches. MAD, we don't want to deplete all 3 inches, is half of that. So the soil water deficit at MAD would be 1.5 inches of water. So that gives you an idea of how much water you can deplete, how much ET you can take before you need to apply, and then also, should be the maximum amount of water that you would want to apply in any irrigation event. And if you're running, let's say 24-hour sets and you're applying 2 inches of water in this scenario, you would be losing a half an inch of water every time you irrigate. So that would also be interesting to know. So I'm going to skip that. So Sean and I, a few years back, and he's speaking, built this. We know that calculating reference ET, keeping track of what your soil water content is, and then modeling that is a lot of work, and most people don't want to do that. And so we built this tool, Irrigation Scheduler Mobile, to do that. It uses weather stations throughout the West. And the idea is when this is field capacity, here's permanent wilting point. So we just use full and dead. In this case, MAD is 50%. So anywhere in here, you're fat and happy. You see increasing amounts of water stress down here. So this is kind of the gas gauge way to look at it. We tried to make it really simple and easy to set up by just providing a bunch of defaults for like soil water holding capacity and crop coefficients and things, so that all you have to do is you name it, like the back 40. This would be 2024. This is the year. We select AgWeatherNet. We choose the station that's nearest us, and we choose our crop. Let's say alfalfa, and our soil. Let's say it's a silt loam, and it's going to add the field, and it's going to set it up for us with some default season dates for when we think alfalfa is going to start growing, and what the crop coefficients are, what the water holding capacity is for your soil, the field capacity, MAD, wilting point, rooting zone depths and stuff. We kind of get that started for you. But then, of course, we hope everyone clicks on this field settings and goes in there and looks at those numbers and say, okay, that doesn't make sense for my field because we're doing something different. Please change those. And then it pulls from AgWeatherNet, the weather station. It uses all that weather data, calculates reference ET, multiplies it by the crop coefficient, and also a stress coefficient, which if you're interested, click on this help button. It'll give you some more information about it. But anyway, that gives you the crop water use in here. If it's green, you're good. As it gets near the that red line, it's going to get from yellow to red. And then irrigated here, we applied 1 inch of water, and then it pushed it back up again. The number that we find that most growers think is interesting and useful is this soil water deficit, or how far down you are from full, or how much space there is in the soil. So as ET, so this number plus the ET is going to give you this number. So in other words, and if I was going to irrigate today, this is how much water I would apply. And then here's that graph. Here's field capacity. In this case, it slopes up because we have a very simple model of root growth. We assume that it grows linearly until it reaches this point where it's full cover, and then it stops. But anyway, what you're trying to do is keep the soil water content between the field capacity and this MAD line for maximum production. If you want to impose water stress, then you'd want to deliberately put it down here below the red line. You click on the date or edit, and it allows you to put in your irrigation amounts. So one thing, we aren't connected to every single irrigation system in the state, so we don't know when you apply irrigation or how much. So you have to enter it here. Or if it's wrong or you just want to, let's say you didn't keep track of things the beginning of the season, you just want to start from today. You say, well, I think it's about 50%. You can reset or correct the soil water availability and set it to whatever you think it is, and then it'll model from that point on forward. There's some more data here about those numbers. A lot of different charts. The cumulative water, ET, irrigation and rainfall, shows what the crop coefficients are in the root growth model. Daily crop water used, cumulative and deep percolation events, water stress, and then when you experience water stress, and it'll estimate a total season yield reduction using very simple model for yield reduction due to water stress. Crop coefficients, in this case, there is a for forages. There's cutting dates. It allows you, when you click edit, it knows what crops or forages, and it'll allow you to edit, to put in cutting dates, because when you cut alfalfa, it goes from this tall to this tall, and obviously short alfalfa uses less water than tall alfalfa, so it does that. And then there's help screens. If you want to find it, just Google it, irrigation scheduler mobile, and then you can find it. So with that, I am done.
Okay, thank you, Dr. Peters. So if you have any question for Dr. Peters, just use the chat window. So we'll go on with Sean's presentation, and then towards the end, we take all the questions together. So meantime, but if you have any question, just put in the chat window there. Yeah. Okay. All right, so let's move on. Sean, you are ready?
Wow, yeah, that's great. Every time I listen to Dr. Peters, I feel like I learned something. And so I just want to say thanks for that great talk you just gave.
Well, and full credit to Sean, who built this thing. He's the
You're too kind. I
genius.
still don't understand everything, so I appreciate it. So hello, everybody. Thank you for taking the time to join us. I'm Sean Hill with the AgWeatherNet program. I think we've met most everybody, or all the names look familiar to me, so thanks for joining. My talk is more focused on just some of the tools that we have on our web page. I think everybody's familiar. Weather.wsu.edu is our front page and a map. And I'm just going to click through and show you several of the tools that we have available that talk about water use or irrigation and things like that. So before we get into that, I'll just highlight that we have this events section. If anybody's looking to see what's coming up, it'll be posted here as soon as we have information. I don't think we're scheduled with a topic next month, but Lav may have information at the end. So one good way with our page to keep an eye on your water use is our weather data page, which is linked directly to each of the weather stations. Our colleague Akash has done a great job of kind of rebuilding a bit of this interface that you see. And you can select any of our weather stations right out of the drop-down list, or if you don't know where your nearest weather station is, you can use a mapping interface, which will let you enter perhaps your zip code, and you can select a radius that you're interested in. And then you can click the search button, it'll zoom right in, and you can add or remove stations just by clicking into it. After you have your station selected, which I already have, you can choose several options to look at the data. For water use, we're going to look at daily data specifically. You see that there are date ranges available and several quick date selection options. By default, we look at these 6 days ending in today. So on this form, like most of our forms, each of these tabs represents one of the weather stations you're interested in. And let's, for the sake of this, look at Prosser. And you can just notice right away that we have the ETO, which is, as mentioned, for grass, and the ETR is the alfalfa value in inches. So you can see daily ETR, ETO values just real quickly right from here. Important to let everybody know that you can change which data you're looking at on this form. So if you have too many columns for your screen size, just click on this little edit customize button, and you can go through and choose which variables are seen. If you're interested in any more information about this, please do just write to weather@wsu.edu. Now we have another tool here found in the station specific area. We call it climatology. Again, you can choose your weather stations by selection or map. We can choose what season we're talking about. I'm going to look at the current season to start with. And what this does is look at the entire period of record for the weather station and charts out what is a normal value based on the imaginary average year that could happen. So this chart can show you both the precipitation values here and the ET water use down here. So we're into the end of May in 2024, and you can see that we're a little bit higher than what the normal would be as far as water use. And we're also happen to be just barely higher in this what precipitation has happened. Next tool I'm going to show is the legacy water use model, not as sophisticated as the irrigation scheduling tool, but it can be useful in some situations. What it lets you do is come in, again, select your weather station and your date range of interest. By default, it'll choose the current date and the forward-looking next forecast 6 days. And you'll notice that there's the option to choose all crops or selected crops. If I change to selected crops, here's all of the available options. You can use default emergence and harvest dates, or you can customize them when you are in the selected crops option. This particular screen is for all crops. As you can see, they're listed down the side. How much water use is yesterday. Today is not completed yet, so we still consider the forecast values, and then it sums the total here for you, and it will tell you what the emergence and harvest dates would be. You can download this data for use in your preferred offline tools, and again, just to note that you can see several of your stations at once if you like. If you were to choose a specific set of crops, here I've chosen blueberry and raspberry. You can come and see that it charts again the past day and the forecast. And for each of these columns, blueberries, the individual days value, and then the accumulated water use over that period of time. Then again, raspberries, individual days use, and then the accumulation. Just by changing these dates here, you can see it gives you additional data. So it's all there, and again, available to download for use in your reporting or offline tools. Another way similar to look at evapotranspiration alone, if you're not crop specific, is the evapotranspiration table, available under the models irrigation ET table. And again, very similar. It can be a date range, and it shows the estimated ETO, ETR, and the accumulation over that time period. If you're more of a graphical interface person, we have the ET chart in the same area, which will plot the ETO and the ETR and sum it over time. If you're interested in longer time range, you can click any of these quick buttons. I normally don't do these things live because, of course, it'll go a little slower, but you can see over the past 1 year what the water use would be. For things like site selection, we have a tool on our webpage called the average ETC by month, right? And this is based on the crops that are in the ISM tool that Dr. Peters was showing. And what it does is, again, for each weather station, for the entire period of record of that station, it calculates the imaginary average water use based on those default crop coefficients, emergence dates, and things like that. And here again is all of the variety of crops that are available. And it will look at each month how much water use. You see in January, there's no water use because there's no emergence. And then finally in April for alfalfa is when we start using water, and give you an estimate of what the annual water use at that location for that crop would be. As you look at this, you could decide, you know, we get not enough water for cherries, or I do or don't have enough irrigation supply for particular crops. Annualized evapotranspiration, another chart that you can look at based on the, oops, I clicked, the history of the station. You can go backwards in time and see what the estimates for past years might be. I was going to show just a quick look at that irrigation scheduler. In our full web page is located under this models, then irrigation, then irrigation scheduler. As shown, you can just enter your field, choose from any of these weather networks, choose your weather station, select your crop and your soil type, and just hit add field. I have 2 sample fields set up right here. So we're on alfalfa. If we could look at the soil water chart at all of these tools that have already been shown, so I'll just quickly go through them. Here's the various settings that you could customize. And then I wanted to note that those do directly feed into the mobile friendly version. You'll notice that they're the same fields. And again, the daily budget table along with the forecast values are available. Looking at the time, I think I have a moment. Future releases, now we're looking at the development server. One of the things we're really trying to work on is a spatial representation of fields and blocks so that you as users can better manage each of your locations as you see fit. And so I just wanted to take a moment and show you that we are kind of working on this. You can, I hope this works while we're on demo. You can draw yourself a new plot, give it a name, weather, school, hit save, and then as you lock those plots back up, this is really just a proof of concept that we can get in there, and then as you see, you can then click in and get details of what's going on in those things. Be able to select perhaps what crop you're using, what your planting and harvest dates are. And that's just a future tool that you may be seeing soon. And we're hoping to get any feedback or ideas as far as this sort of interface goes. What would be valuable to you as a user, and how can we improve? And I think with that, I'll just kind of pause and stop sharing my screen and see if we can have any discussion together. Perhaps I will zoom bars in there. There it is. So thank you.
Yeah, thank you, Sean. So let's also bring Dr. Peters on there. So yeah, we have some time if you have any question for both the speakers. Yeah. It's always that first question. Okay, there's one from Andrea, I think. Do you see any common user errors with the irrigation scheduling tool? Who want to take that one?
I would say that from my perspective as like the support person, I don't see anything that's a common error necessarily, but some people, how do you say it correctly, don't enter their irrigation events regularly, and so there's an impact on the quality of the estimations based on what sort of water is available. And maybe Dr. Peters has additional comments.
Yeah, that's the biggest thing is you have to kind of use it and keep up with it. And we've done some things because like with center pivots, for example, it's coming around and it's irrigating like every other day. We tried to make it some modifications so that there's you can schedule irrigations and to try to help overcome that hassle factor of entering. And we did the on-off type method. So there's all some ways. So look in the general settings and look under kind of the different options that are there. And there's some ways that if you play with it, it'll be a little easier to enter those irrigation events.
Kelly is following up on that one, saying that, and that's, I mean, Sean, you or Dr. Peters can answer that. Is it because of the, the data entry issues that someone may inadvertently apply the water? Because we miss irrigation events and such, yeah.
I think that's a possibility.
We don't dig into the data with individual growers. We just kind of put the tool out there and let them use it. And so we haven't done a lot of, we think that they did this and therefore, but we just see a lot of people use it for a few, it's like exercising or whatever, use it for a little while and then they stop using it. It's just kind of a general trend that we see. And that's okay if they kind of get the idea and it's useful for a while, then that's okay.
There's a compliment from Johnny, and then he's following up on, this is a question, probably Dr. Peters, you can take this on. How do you see the difference of your spatial map development? Well, this is what Sean showed versus the OpenET approach. I think Sean probably, maybe Dr. Peters, maybe you can explain what OpenET is, probably, I guess, right?
Yeah,
Maybe,
so OpenET is a tool that was developed with funding from NASA that uses satellite-based multispectral imagery to estimate ET from Landsat data imagery as it comes across. So every 8 to 10 days, Lav, that they get those images, they can get an estimate of what ET is at that time. And then they use some ways to try to interpolate between those times, and if there's clouds and stuff, that gets in the way. But it's a way to, and then they've kind of put that over the top of these big maps, similar to what Sean's done, so that you can drill in and pick individual fields and say, okay, how much water did it use over the last year? And it'll give you an estimate of that. It's not, I mean, you shouldn't take those estimates to the bank, but it's interesting still.
Yeah, thank you. And just on the same lines, I think, Sean, you showed this, but I think I will again ask Dr. Peters to start on this. Because we have a project that we just got funded now, and that's the reason we are trying to get the spatial maps inbuilt. Dr. Peters, you want to talk about that project? Because there's a question on, could we pull the data from the web soil survey for soil types and available water capacity and such on those spatial maps that Sean was trying to show? Yeah.
Yeah, so we can, one potential use of the OpenET data is for us to help correct crop coefficients. Crop coefficients are kind of the biggest unknown or one of the biggest variables that it's hard to get those dialed in, because planting density, crop variety, when you plant, all these things can affect crop coefficients. We can kind of use OpenET data as a way to help us bracket those. Again, I would say they're plus or minus 20%. So not super accurate, but still kind of useful for that. Yeah, and then, but there's also web soil survey data. So there's soils data, that database that we can pull information for the NRCS soils data. And so anyway, this is kind of us moving, Sean and AgWeatherNet moving towards getting those a little bit better. We're all actually also trying to integrate into this irrigation scheduler a nitrogen balance component as well. So
Yeah, so yeah, we have this grant from WSTA actually, and we'll be like whatever you saw today, some of those interfaces will be linked together better and improve the user experience and all those things. You will see some of that for sure. That's where we are going actually. So anyway,
yeah.
yeah. So Kelly has a follow-up on the previous scenario, users entering or not entering the data. Just curious to see if you have heard of use cases where this happened. I don't know what that
Where
scenario was, but yeah.
over applying.
Yeah, so
Yeah, I haven't heard of any direct ones. Because I mean, we don't do a lot of hand holding with individual growers or work with them directly. We just created a tool and put it out there. And we try to get as much feedback as we can, but we haven't been aggressive, and it's free. And so, I mean, it's hard for us even to, most of this has kind of been bootstrapped anyway. It's, in other words, there's not direct funding for a lot of this stuff but we've just done it because it's, and so anyway, there's not funds for us to go out and work with growers directly on this. We would like to, if we can find some, we'd be happy to do that.
great. Yeah. Yes, Johnny. Yes, we will have the recording after like maybe 2-3 days. We just do some editing and then we post it on the AgWeatherNet. Yeah. So great. Any other question for Dr. Peters or Sean before we close for today?
Thank you everyone for coming. We honestly, if you have feedback, we love to hear it. You'd say, ooh, I think the way that this works is a little weird or wonky. What if you did it this way? That's really great feedback, and we're definitely open to that.
Yes, yeah, and I'm typing the email. There's Sean monitors this email every day religiously. So if you have any feedback that you want to give on the portal that he's managing or anything related to Dr. Troy Peters' scenario that he's helping, yeah, please shoot an email and he will take care of things as appropriate. So yeah. With that, I think, yeah, thanks again for joining. We do not have anything planned for next month. We'll see if something comes up. We'll have the events calendar updated. But if not, we will reconvene. I think we're hoping to do next Weather with AgWeather event in September on the cold harness model scenarios. So we'll see. Yeah. Again, thanks for joining. Yeah.